Hello developers, let's start developing. Today is the 3rd of December. Unlike previous days when I was in Skopje and Zagreb, now I'm in Tel Aviv via Sofia, so it's been quite an eventful week for me. But I will be taking my first look at the task number 3. So this is the first time I'm seeing it, just as I'm recording this video. So we have loading rucksacks. Yay! I've been spending a lot of time with rucksacks in the last few days, so I know all about them. With supplies for the jungle journey. Unfortunately, now be arranged. Each rucksack has two large compartments. That's true. Usually you take hide the laptop in one and the underwear in the other. Meant to go exactly into one of these two compartments. Aha. So means that we should, if we have an item of a type, it should go either into compartment 1 or into compartment 2, but not in both. Those manually currently in each rucksack your person help finding the errors. Every item type is a single lowercase or uppercase letter. So A and A are different. That's cool. Characters all on a single line. A given rucksack always has the same number of items in each of its two compartments. So this means that if we have this string, half of it will be in one and half of it will be in another. Yeah. So this is one compartment and this is the second compartment. The first rucksack onto the air, yep. In bone compass is lowercase p, lowercase l, p. Can go entered into a priority. Sum of the priorities. So what we basically need to do is for each of these to see whether it's here. So whether we have a V, we don't, so we might just remove it. Whether we have a J, we don't, so let's remove it. Whether we have an R, we don't, so remove it and remove this. Do we have a W? What's the actual? Yeah, it's the P. And whether we have a P, yeah, we do. So that is the one and only. And we don't have to go through all of these letters because finding the first one is actually finding the only one. So how can we do this effectively? Well, for one, let's try it with a simple and stupid solution, and we will optimize it if it's way too slow. So my instinct is always to try with a simple and stupid solution. Unfortunately, I will be using as much as possible pure functions, which means that we can refactor the functions if we see that they are lacking something. So we will have our day3 input now. And I will write this in Latin alphabet. So we are saying that our input is this. So what we will have as type of our input. So basically we can have an interface that is a rucksack. Is that how it's spelled? Rucksack, yeah. Which has two compartments, and the first one is a string and the second one is a string. And this we will be returning an array of rucksacks, and this is for day 3. So this means that we will have a rucksack here, a rucksack there, a rucksack just about anywhere. Part 2 will have a rucksack as an input. We can delete this and just return a 0, so this compiles, or even a -1. Since the result should be a sum of positive values, -1 is clearly not the correct answer. This is a rucksack, so we are having -1. We don't need this method, so we're just back to where we started. Of course, I could have done this with just input, but I choose to go the long way around. We are gonna set that the solution 3 will be the solution that we're using in building. So let's see if this thing actually works. Run an npm start. Nope. Yeah, we have a problem here. So let's see. We are mapping the lines. We need to map them differently. So we need the length of the line. Yeah, that's the line length. And yes, the first will be the first half, and the second will be the second half. And we need to return the first and the second as rucksack. So once we have our logic correctly, Copilot, it helps us immensely to actually write the code. So this saved me some typing. It saved me zero time in thinking about stuff. But still, let's see if this actually runs the way we want it to run. We want to see the input that we gave and got. This is up to the R, this is starting with the H, and it was supposed to be up to the R and starting with the H. Yeah, looks like our code so far is correct, so we correctly have our input data. And now we need to actually solve the thing. So what I'm gonna do? Well, I'm gonna be stupid. Let total equals 0, return total. So what are the steps that we need to do? We need to find a letter that's here, but it's also here. And we are assured that in our input we will have exactly one such case. So let's try that. Yeah, we're gonna need a for of. For each rucksack of input. Actually, we can deconstruct this immediately and have this as a first and second. So we have the first and second thing. So the characters of the first one are the first one split on each character. We don't need that, but we can do another for of. We can have each character loop through the first string. How many characters it has, it's irrelevant. It will just go on and on. So this is not terribly performant, but it's very simple. For each of those characters, see whether that character includes the character that we're looking for. If it does, then we are done here. So to the total number, we need to add not one, as GitHub guessed incorrectly, but we need to add to the priority of the item. And the priority is, if it's A, it's 1. If it's Z, it's 26. If it's A capital, it's 77. If it's Z capital, it's 52. So we're gonna do a bit of JavaScript magic here. Because if we have A and we do to char code, uh, oh, char code at 0, give me the character code of the first item. That will give me the 97. So this means that if this is a lowercase and if I subtract 96 from this, for A I will get 1 and for Z I will get 26. But what happens if I do an A? What happens if I do a Z? I get negative numbers. But for an A, I'm getting 65. So what happens if I subtract how much is 65 minus 27? Oh, that's a strong one. I think it's 38. So if we subtract 38 from that, then we get the correct value. And of course, for Z, we're going to get 52, which is the one we want. So what we want to do? We first want to see if our character is equal to its lowercase variant. If these things are equals, that means that we have a lowercase letter. And we add it subtracting 96. Otherwise, well, this time again, this thing guessed and guessed wrongly. Because we don't, this will transfer, if we try it with 64, this will transfer A to Z through 1 to 26. But we don't want that, so our coefficient won't be 64, it will actually be 38. So, and once we've done this, if the second includes the character, we can just break the loop because right now it's not really important. We found the character that we were looking for, so we can go to the next input set. Let's see if this makes any sense. Did we change the return value? Yep, we're returning total and we're starting total at 0, so this might even give us the correct number. It says 157 and the one that we were supposed to get is 157. This is great. Seems like the first part of our task is up and running. Let's add the real input and let's start it. I'm not gonna show the input parsing now. We will just process it and it says it's 8085. Let's see if that gives us a star. Yeah, that's the right answer. We have 5 gold star now. Let's continue to part 2. Let's see how we complicate this. Another issue. For safety, are divided into groups of 3. Every elf carries a badge that identifies their group. For efficiency, within in group of 3 elves, but which is the only item carried by all 3 elves. What? I'm gonna need an example of this. The problem is that someone forgot to put this year's updated authenticity sticker on the badges. All of the badges need to be pulled out of the rucksack so the new authenticity stickers can be attached. Which item corresponds to each group's badges? Aha. Every set of 3 lines in your list correspond to a single group. Hmm. So we have the groups. This means that we have 6 lines, and the first 3 lines are one group of elves, and the second 3 lines is another group of elves. Okay. And it seems that we don't really care about the compartment. For example, the only item type that appears in all 3 rucksacks is lowercase r. This must be their badge, and the second group, their badge item type must be Z. Uh-huh. Okay. I think I know what to do. And this is something I love about Advent of Code. So now, instead of solving part 2, I will be resolving part 1. Because here we have we are having 2 lists of characters and we are comparing each to each. But now, for the second part, we need to do that for 3 groups of characters. So that means I have 2 nested fors here. I will have to have 3 nested fors. And nobody likes writing 3 nested fors unless it's XYZ. Processing, some kind of 3-dimensional processing. Because that will be quite error prone. So I don't want to go that way. I want to go another way. And that way will actually be better for me if I rewrite part 1. So what I will do, I will make a getHistogram method that for a given string will give me back a histogram. Let's see. Yep, something like that. Once I named my thingy correctly, it kinda worked. Actually, I don't even need this. I don't need it to be explicit map because this is even counting the numbers and I don't really need that. I can use a simple object here that is of type record string and boolean. The boolean is not really needed. Actually, do I need a... Yeah, I need a set. It can be a new set of string. Actually, I can just do this. So a set is a thing when if you set something multiple items, multiple times, it will just have it once. And it has all of one complexity of getting types, getting things. So I will have that method and I will make another method. Yeah, this is that what I want, and I will call this first and second. And the body will be, yeah, we have the new result for each of the first. If the second has it, then add it to the result, and that's all there is. So we're looping through the first, and if the second set has it, add it to the first. And this is relatively fast implementation. So what we're gonna want to do here. So we're not gonna do splits. We're gonna be declaring 2 variables here, hist. And actually, since we're here, let's refactor this. I don't want to surround it with anything. I want to extract it into a method. It's something called priority. That's a string. We can use this thingy, and this is not input, this is char. This is a weird little function that only uses the first letter of the string, but all of the strings that we're going to be calling it with will be one character string, so we don't really care. So what we're going to do, we're going to get the histogram of the first, we're going to get the histogram of the second, we're going to get the intersection. Actually, we're going to get the common letter of this. We know that this will be a single character. So that means, just a second. Am I reading this correctly? Aha, okay. We have an issue here because right now the rucksack concept doesn't, the compartments of the rucksack don't really make sense. It's much better thing to just return the input here. So we don't need to map anything, and we will be doing that here. So that means that we're not going to be using a list of rucksack, we're going to be using a list of strings. That means this is a string, and this is a string, and this is a string, and that's about it. Yeah, one of the dangers with solving the first part is that you may kind of make some assumptions about what the second part will be, and if that doesn't work, it doesn't. So what we're gonna need to do is we're gonna need to have a list of rucksacks here, and we're gonna use the input and map each line to this. So we have the exact same code, but we kind of moved it around. So now the input is simple strings, but the rucksack creation is in the first part. It's not counted against the second part because the second part doesn't even need rucksacks. So we are getting the common. The common will always be a single character. And now we can say, so this is a set. This won't really work here. But what we can do, we can say, treat this set as a array and take the first letter. And that's a string. And now what we need to do is get that letter's priority, and we have a solution that I hope it will work. Actually, no idea this time. The answer we're looking for, because we changed the input to be our smaller input, is 157 if I'm not mistaken. Yes, it's 157, and the value we got is 157. So the good thing, if when you solve your problem in a stupid and slow way, is that you have a baseline. I know that my value is correct, so I can never go back to not having a correct value. But now I can play around with my data, with my input, with my output, and see where it takes me. And I always know that I can always, at the very worst, I can go back to something that was slow and functional. So for the second part, so basically we need to take three items. So I'm gonna use for this I'm gonna use a while loop. So the index will be 0, and while index is less than input.length, we're just gonna loop. Since the task kinda guarantees that we will have groups of 3, let's abuse that. If there are not enough things to have a group of 3, then yeah, our program will blow up. So we can say fhist is get histogram of the input at the index value. Shist and not common, but we're gonna have another. The first, a second, and a third. That takes it at index plus 2. And of course we will end this with index plus equals 3. So we're not increasing, we're processing them 3 at a time. So now we can say common is an intersection between the first and the second, and it's actually an intersection between the first and the second and the third. Text. So this will give us something that is common for all 3 rucksacks that we have. And it seems the only thing that is common is the lowercase r. And next is the z. Let's actually grab that and add it to the total. Oh yeah, we need the total as well. And we need to return it. But this code, I don't have the best feeling about this. So I will need to see whether it's correct or not. Let's see the actual letter. If we get an R and a Z, that means that most likely we're doing something correct. We get an R and we get a Z and we get a result of 70. Kinda looks okay. So let's remove this console log. Let's go for the 300 rucksack worth of input and let's start our code and see whether we get some results. The total processing time is 15-18 milliseconds and it says that the result for the second part is 25-15. Let's see if that could be our solution. And that's the right answer. We have 6 stars now and we solved the task number 3. So for now, I'm gonna say goodbye and we will see each other tomorrow. And when I will still be in Tel Aviv and I will be solving the 4th task.